In lesson 2.8, it is all about mental math, and I have stressed to the students that this is not anything I'm going to require, but some of them were able to catch on, and it really made a lot of sense to them. I even admitted to them that this is probably nothing I would have done as a kid because I am not a mental person. I like to look more visually at everything, but I am going to go through each strategy so that the students can see some examples that we did in class with some explanations. The first method that they could try is changing the order, and that's really the commutative property. So looking at 4 times 7 times 25, I see that I could change the order and I could do 4 times 25 and then I'll multiply times 7. So I'm going to put my parentheses around my 4 times 25, and I just think quarters, money, that type of thing, and I see that 4 times 25, or I know that it is 100, and then I'll times that by 7, and that equals 700. So this is trying to teach them what strategies they could use in their head. I'm just writing it out at this point. Here's another example of changing the order. I see that I could really do 4 times 50 first, because that makes sense to me, and then I'll times that by 6, so I'll put parentheses around that. I know 4 times 50 is 200, then I'll multiply that times 6. I sometimes like to circle my basic facts, so I know 2 times 6 is 12, and then I have 2 zeros between the two factors, so I need to place 2 zeros, and we just technically went mental, or we're trying to teach the kids what they could do in their head to solve these problems. Your next method would be compatible numbers, using numbers that make sense to you. So for this example, I'm going to distribute or break apart 32 into a factor that I can work more easily with. So I'm going to do 8 times 4, which takes care of my 32, and then I'll multiply times 25. Now, this takes us back to working with compatible numbers, or numbers that make sense to us. I know that 25 times 4 is 100, so I'll do 8 times 100, and that gets me my final answer of 800. So breaking apart numbers into factors, smaller numbers that make sense to you, and then multiplying. Another example would be 8 times 25 times 23. Well, the compatible number, or the number that makes sense to me, is 25. I usually know, and what I tell the kids in class, you could do 4 times 25, which is 100. Well, we're doubling that to 8, so 8 times 25 is 200 times 23. And in class, I changed it visually, because again, I'm a visual person, and I asked them what 23 times 2 is. If they can double it in their head, that's totally fine as well. But then I see that that's 46, and then I have the 2 zeros from there. And so I was able to go mental with this problem. If they need to write a few things out, that's totally fine. If they don't want to use this at all, that's totally fine. We could figure out what 8 times 25 is, and then use an area model, or just regular multiplication to figure out our products. One of my favorites that does really make sense to me is the halving and doubling. We're going to take half of 14, which is 7, and we're going to multiply that times 50. So then our basic fact is 7 times 5, and that equals 35, but then I have a 0 between both factors. So that's my halving, and now I'm going to double that. And so I just add that up, and I get 700. Another example of halving and doubling. And it seems to, it works better when you have one of the factors that is has a 0, because then they still can go mental. So I'm going to take half of 16, which is 8, multiply that times 50. So my basic fact is 8 times 5, which is 40. And then I have a 0, so I'm going to put that there. So that was halving it, and now I'm going to double it. And so then 16 times 50 is 800. The fourth option is changing or breaking apart one of the numbers with addition. The kids look at this kind of as expanded form, or distributing, or breaking it apart. So my original problem was 5 times 420, but I'm going to distribute or break apart 420 into smaller bits. So now I will do 5 times the 400 And then I will do 5 times 20. So 5 times 4, if that's what they need to look at first, 5 times 4 is 20, and then you have 2 zeros. And over here, 5 times 20 is 100. And then you put them together and get 2,100. Here's another example of addition, breaking apart that 625. We're now going to change it to 4 times 600 plus 25. So I'm going to go ahead and rewrite this as 4 times 600. And then I will also do 4 times 25, and that's a compatible number for me, or a number that I can easily compute. 4 times 6 is 24, and I had 2 zeros between the two factors. Plus my 4 times 25, I'm just going to go ahead and write that out. I know that's 100. Add that together, I get 2,500. Now, again, it is totally fine if they just want to do a regrouping method and do 625 times 4. I totally get that. That's what I would have done as a child. Or if they want to use their area or box method, that is absolutely fine too. This is just trying to show them another method they can use. The last one, I did not spend a whole lot of time on this, but it does make sense if we would do more problems like this, is subtraction. So since 298 is really close to 300, I'm just going to go ahead and do that mentally. 6 times 300 is 1,800. But that was 2 times too many, since that was 2 away from 300. So 2 of those times, 2 of the 6's need to go away. So 2 times 6 was 12. And you're going to subtract that out to get your 1,000. And if they have to, I mean, again, sometimes this doesn't make sense because for some kids it could take more time, but for others it might not. They could see this visually without having to regroup. That would be, that is not correct. I'm sorry, that should be an 8 there. 1,788. Kind of confusing if they don't understand. I'll give you one more option here, or example. 199 was really close to 200. So I'm just going to go ahead and do 3 times 200, which is 600. But that was 1 time too many, since it was 199 to 200. So I'm just going to take one of those 3's away, and I get 597. If you would check it with a calculator, you would get the same product. I've told kids, though, if this doesn't make sense, just go ahead and do your 199 times 3, do your regrouping. That's absolutely fine. I'm just trying to give some examples like the Go Math book is doing. Hopefully this was not confusing. If it was, then just skip it and just do regular multiplication. That is absolutely fine. Thank you.